Okay, so now we know the definition. Let's actually see what we can use to quantify, to express this. So the convection heat flux rate equation can be expressed by Newton's law of cooling. We said conduction alone can be expressed by Fourier's law, and now Newton's law can be used to express convection. And you'll see that Newton's law is actually very simple. It is saying that the heat flux is equal to a proportionality coefficient, which we're going to call convection heat transfer coefficient, multiplied by the difference in temperature from the solid surface with the air or the fluid that's traveling over the solid surface. Now, this might be too small for you to see, but there is a bar over here over the convection coefficient, and this bar just represents that this convection coefficient is the average convection coefficient along the surface. And this is because, as I will explain in another chapter when I talk about the boundary layer theory, but what actually is happening is the convection coefficient changes as the fluid travels across the surface. And so what you need to use over here when you're using this equation, you need to use the average convection coefficient. I'm sorry, it's annoying if you don't see this bar over the convection coefficient, but essentially this bar just means that I'm using an average convection coefficient value. And I will talk a little bit more about I'll slightly touch on what the convection coefficient is right now, but also when I talk about the boundary layer theory, I will dive deeper into this convection coefficient. But just for now, I want you to know that this convection coefficient depends on conditions in the boundary layer, which these conditions are influenced by the surface geometry, the nature of the fluid in motion, and some fluid dynamics and some fluid thermodynamic and transport properties that determine what this value for the heat transfer convection coefficient will be. And finally, Ts is the temperature of the surface, and T infinity is the temperature of the fluid that's traveling over the surface. In terms of heat flow, as we said, is the heat flux multiplied by the surface area. So if you multiply the surface area with the heat flux, you get the average heat transfer coefficient multiplied by the surface area, multiplied by the difference in the temperature from the surface to the air. And if we expand the surface area over here, we'll get that the surface area is just, in this particular example, is pi dl, because this is a circular rod and it's occurring at the surface of the rod. So it's going to be pi times the diameter of the rod multiplied by the length of the rod. So before going into further details about convection, let's try to solve this simple example.